we go. Welcome back, and here we are in part 2. And this part we will introduce a matrix inverse and where can we use the inverse, which is representing a system of equations, and in cryptology. So an inverse, before we introduce an inverse, we need to know something called identity matrix. An identity matrix is a 2 by 2 matrix where it's known as an I, capital I. The identity matrix is 1, 0, 0, 1. The order is really important. Why? Because an identity is something like 1 in the arithmetic or in numerical numbers. Whatever number you just multiply by 1, it should give you the same number, as well as here in a matrices. Whenever you multiply by the identity matrix, you should have the same matrix. So for example, here we have 2413 multiplied by the identity, the result is 2413. Yeah? All right. The determinant. The determinant of a 2 by 2 matrix, for example, we have a matrix A, B, C, D, is A times D minus B times C. Let's see it in another way. Here we have the determinant. So the determinant is the result of subtraction A times D from B minus C. And we can use this notation. So let's see an example here. For example, if we have a matrix A with 3, 1, 4, 7, the determinant is 3 times 1 minus 7 times 4. And this is equals minus 25. Now, why we did introduce the identity and the determinant? Because to find an inverse, we should have a determinant, and to make sure that we got the right inverse, then the result of multiplication, the matrix with its inverse, should give us the identity. If A is equal A, B, C, D, then A inverse, which is run as power minus 1, should equals to 1 over the determinant of A. And then what we do, we just change the place of D and A and change the sign of C and B. Okay, so the steps to find an inverse of a matrix is, first you exchange the elements in the leading diagonal. The leading diagonal is, if I have an array here, here is the leading diagonal. Then you change the sign of the other two, which is this one. And then we multiply by the determinant. Here is an example. We have a matrix P with minus 1, minus 1, 3, 2. Then we need to find the inverse, P inverse. Finding P inverse following the previous step. In step 1, we did exchange the elements in the leading diagonal. So first we have it as minus 1, 2. Then by applying the first step, we have it as 2 minus 1. Then in step 2, we change the sign of the other two elements, which are here. So we had it as minus 3 and minus 1. On step 3, finding the determinant, which is multiplying 2 by minus 1 and then subtract 1 by minus 3. and the result here is -1. So P inverse is equals to the final step we reached multiplied by the 1 over the determinant, and we got the inverse in here. Now to make sure that our answer is correct, we can just multiply the matrix with its inverse. So P times P minus 1, and we should expect that the identity inverse will be the result. Sorry, the identity matrix. So here multiplying the matrix by inverse, we took the row and multiply by a full column, and then we get the first entry, then the row with the second column, and here we have the second entry, then the second row with the first column, and the second row with the second column, and we got the rest of entries. So the answer is 1001, which is identity matrix, and that shows us that we are correct. Now where we can use inverse, the first application is representing a system of equations. So the system of linear equations, something look like this. Whenever I have a variable and I need to find x and y is equal, so the value of x and y. So this linear equation can be represented completely by the matrix equation. Here we have the coefficient matrix, which is the numbers beside a variable. We put it in a matrix of 2 by 2. Then we got the variable, which is x, and here we got the results, which is 5 and 0. Now we just convert the linear equation to a form of ax equal b, where a is the coefficient of a variable, x is the variable, and b is the results. Right, now let's see how we can use the inverse to solve the linear equation in here. We have this 2x plus 2y equal 4, and half of x plus y equal 3. We can write this system of linear equation in a matrix equation by having the coefficient together, variables, and the results. To get the answer, we need to find what? A inverse. Finding A inverse, we will convert the equations to x equals A inverse times B, and be careful in here because the order is really important. Yeah, and we came up with this since we just multiply both sides by the inverse. So ax equal b, by multiplying A inverse on both sides, A inverse multiplied by a matrix will give us the identity, which whenever we multiply by an identity, we got the same answer. Therefore, we resulted with x will be equal to A inverse times b. Okay, now let's try to solve this. We have a matrix A with 2, half, 2, 1. Then the inverse is, step 1, what do? We exchange the element in the leading diagonal. Alright, and step 2, we change the sign of the other two elements. Then we should find the determinant, which is multiplying 1 by 2, subtracting half by -2, and then we got the determinant 1. Then we find the matrix by multiplying the last matrix by 1 over determinant. Then we got the inverse. All right. In the case of our example, we know that A inverse, and we know that to find the result, which is the value of x and y, we need to use the inverse. So x and y is equals to inverse times b, which is the result. Yeah. So in order to multiply, make sure that the size is compatible, and it is here compatible because the size of first matrix is 2 by 2 and the second is 2 by 1. All right. So taking the first row, multiply by the column, getting the first element or first entry. Then the second row by a column, getting the second entry. And we got the result as -2 and 4. Now, x is equals to -2 and y is equals to 4. And here we saw the use of inverse on solving a system of equations. The other application that can be used inverse is the cryptology. Matrix inverse can be used to encode and decode a message. Now to start up, we need to set up a code. How to set up a code? For letters in English, we just can give them a corresponding numbers. So we do have 26 letters. So starting from A to Z, we can put the corresponding numbers, which is from 1 to 26. And we can represent the space by 27. Let's see this example. In this code, I have the word secret code. So in order to change the word to a numbers, we just recall our idea, which is numbering the letters from 1 to 26, like giving each letter a value. So for S, I do have the number 19, E 5, C 3, R 18, E 5, T 20. Then we have a space 27, and then we have C 3, O 15, D 4, and E 5. So we just rewrite the code in numbers. Yeah. And see where we use 27 on representing a space. Alright, so now we need to convert those positive integers to a 2 by 2 matrix will be used to encode a matrix. But before, we just need to convert those numbers to a matrix. So we put it as 2 rows. Once we end up with the 2 rows, then we go for the second column. In case we have an empty element, then we can just put a 27 in there. Alright, for our example here, to encode a secret code, we will use a matrix as 4131. Now we are ready to encode this message. To do so, we just multiply the matrix by the code that we create, or the matrix code that we created. Then we got the encryption of a secret code, which is 91, 24, 66, 21, 80, 25, 117, 30, 72, 90, 101, and 32. To decode a message, simply we need to use the inverse. Alright, so if you notice here, the really important things on encoding and decoding is the key, which is the matrix used to encode and decode. For example, if we have a matrix A as an encoding matrix, let's try to again encode and see how we can just decode this message. So in order to encode a message like discrete math, then we need to order the letters in a matrix of 2 by 2. Recall the values of the letters and put them in a matrix, and for space we use 27. In order to encode, we just multiply the resulted matrix by the matrix key, then we got the encoding message. Alright? For decoding, we need to find first the inverse, and finding the inverse is 1 over determine, changing the leading numbers and change the sign of the rest of elements, and we got this inverse. Then we need just to multiply the encoding message by the inverse, and we got this matrix. Then what do? We convert those values to letters, and we got this message. And yes, we did it. You did it. All right. Hope the explanation was clear to you guys. And here we reach the end of part 2. We just introduced the inverse concept and the places where can we apply an inverse. Be brave, take risks, and nothing can substitute experiences. Thank you guys. See you in next part.